Now, if you grow up in Huntsville, Alabama, I believe that it really is in the water that you have space in your blood. It's no wonder then that Frank chose aerospace as his corner in journalism and have been doing that for some 20 years, going at it with such gusto and professionalism that his contribution to space journalism was recognized with a Goddard Award, a Von Braun Media Award, plus a Jesse H. Neal Award for Specialized Journalism. Frank, therefore, is, I think, most eminently suited to have an in-depth conversation about space with Dava Newman, the present Deputy Administrator of NASA. Now, Dava was some years ago, when Explore Mars was still a fledgling organization and awfully young, to give us permission to use an image of herself modeling her new spacesuit she was working on. And of course, we put her in this imagery on Mars. Photoshop is great about that. We might not have faked going to the moon. It would have been hard to fake it then, but I'm not sure. We might be easier to fake at least images of Mars. Put me in a chair on Mars would be easy. So for the Women in Mars conference, she modeled for us. We made a nice picture of that. We used it for our program. And me being me, I got a tad overboard as I used her image to make decals for my car. So ever since 2011, I have been driving around the Netherlands with Dava Newman in a spacesuit on Mars on the side, left and right, of my car. And I do get a lot of comments about that. I mean, it does get people talking about Mars, I can tell you that. Of course, Dava, now being Deputy Administrator, is great. But I know for a fact that astronauts love her for her design of a new type, more versatile, easier to maneuver spacesuit. Well, Frank and Dava, I am looking forward to your conversation. Tell us, please, what we can expect for humans on Mars. Frank, Dava?
Morning, everyone. How are you all? It's great to be with you. I'm really looking forward to our discussion. That's what we have in store for you. But before we jump right into it, I'm actually here to tell you thanks. Wanted to give my deep appreciation. This is an incredible summit, and really strongly feel that getting to Mars requires both our hearts and our minds. And I think that's what everyone in this audience brings. And by this, I mean that, it's one thing to get the technology right. I'm going to talk to you a lot about that as an aerospace engineer. That's very, very important. But what we need to do is capture the imagination of the public. Every little girl and boy out there, it's my job, it's your job, it's all of our jobs today. We want to bring them along with us on our journey to Mars. When I was growing up in Helena, Montana, I loved sitting outside, looking at that expansive Montana sky, and just dreaming. I was completely captivated by Apollo and the moon landings. I was just a young girl at the time, but my fascination with space, exploration, and humanity becoming interplanetary started during that great expanse of the human spirit going out beyond Earth to the moon, and now we clearly have our eyes set on Mars as a horizon goal. And by extension, this goal, this passion of mine to encourage young people, especially women, girls, and minorities, because we need everyone. We need a huge, diverse crowd, steady careers, and what I like to call STEAMed, very intentionally. It's science, technology, engineering, arts, math, and design. We need all the artists. I need the visionaries. I need the storytellers. That's who paints our pictures to get us to Mars. And recently, as NASA Deputy Administrator, I put the D on the end. Well, I'm a little STEAMed. We all should be STEAMed. We're not making progress fast enough. I've been working on this a long time, decades for me. And that's the maker generation. So if they don't see themselves as an aerospace engineer, I'm a rocket scientist. Isn't this what a rocket scientist looks like? But if they're a 3D maker, then they're in. I need them. So for me, it's STEAM to recruit everyone on our journey. And with this in mind, I wanted to start and share a quote from Robert Goddard, one of my heroes. So on the afternoon of October 19th, 1899, the young Robert Goddard declares, "I climbed a tall cherry tree in the back of my uncle's barn. It was one of those quiet, colorful afternoons, sheer beauty, which we have in October in New England. And as I looked toward the fields to the east, I imagined how wonderful it would be to make some device which had even the possibility of ascending to Mars." He goes on to say, "I was a different boy when I descended that ladder. Life now had a purpose for me." This summit is a living, breathing extension of that purpose and legacy of rocket scientists and pioneers like Robert Goddard, and people of all ages, from all walks of life, that have dreamed through the generations of someday putting boots on the surface of Mars. Well, at NASA, we need you. Today I'm here to tell you that we're closer than anyone, anywhere, at any time in human history has ever been to sending humans to Mars. After today's summit, I want to encourage you, for those who haven't already downloaded it, go to nasa.gov and our Journey to Mars, written out, read our plans about sending astronauts to the red planet in the 2030s. I can tell you that wherever I go to speak, I hear folks very excited, very engaged. I don't hear any questions anymore about, oh, is that the right destination? Why aren't you doing things my way? Here's my plan. No. What we hear is, how can I help? How can I be part of NASA's journey to Mars? And our answer is simple. NASA needs you. We need every single one of you. What you'll find when you read our Journey to Mars document and plan, it's affordable within the current budgets, it's sustainable, and it's attainable, and it's very inclusive. By this, I mean we need everyone. Whether you're a citizen scientist, a spellow-faced nerd like me, an academic, an entrepreneur, businesswoman, or a poet or a policymaker, there's a place in NASA's Journey to Mars. I know that many of you, like me, are space history buffs, and so you know how we got to the moon, and we did it in a 3-stage process. When President Kennedy challenged NASA to go to the moon, the agency just didn't say, okay, Buzz, Michael, Neil, you're off, bon voyage. It was very intentional. First, Mercury. We had to test the systems just to get humans into space for short periods of time, then extended that for longer times. Second, we had Gemini, and we had to do more complex things. Rendezvous was the first time we had our astronauts conduct EVAs, our spacewalks. Finally, we advanced to Apollo. During this 3rd stage is when we really were working with the power of the Saturn V rockets and initially orbited the moon before we landed. So when you read our Journey to Mars plan, you'll see a same 3-stage process to get humans to Mars. We're very well along in our 1st stage, our Earth-independent stage. This is where we concentrate on our International Space Station, where we've had our astronauts continuously working for the last 16 years. We're testing and developing the technologies that really drive our exploration. So many of you, I'm sure, followed Scott Kelly's 1 year in space mission. I know I did. It's going to be great. We have him back in Washington next week. And the first time, that NASA really got to do a genetics experiment. Each crew of 6 astronauts, cosmonauts, performs about 250 experiments every increment, every mission on station. And again, we've been doing this for the last 16 years. So in the next decade, the 2020s, as we're on space station until 2024, in the proving ground, we go on our space launch system to Earth-Moon orbit, get back into deep space. And there we continue to work on some of the human health issues, but we really concentrate on the technology development and many things, in-space propulsion, deep space habitats, the life support systems, autonomous operations, logistics. We have so much to prove in deep space. And then finally, in the 2030s, we'll move on, become completely Earth independent, That's the huge challenge for us, to get to Mars orbit and then boots on Mars. So to sum up, NASA, we are on our journey to Mars. We're well on our way to our journey to Mars, and you're all invited to come along. And the late, great Sally Ride once said, science is fun, and I agree. Science is fun, and thank you for all of the help and enthusiasm that you're doing to get humans to Mars, to tell our story, to work everyone in collaboration and make it fun for the public, capturing the hearts and the imaginations of the people and the workers here at NASA, in industry, in academia, that are really going to make human beings boots on Mars. Now I'm going to I'm going to join Frank and do some Q&A. Thanks for your attention.
Just to walk through a little bit on the Journey to Mars plan, you talked about the Earth-dependent stage at the space station, and you've sent experiments to the space station, and you're also an expert in human performance, astronaut health. How can the station, in the at least 8 years remaining, be best be used to find out what we need to know in those areas to help people go into Mars through the moon?
Thanks for the question. It's really paramount. We have to be focused. You're going to hear more detailed comments at the summit, but this is the way I look at it. 3 phases, as I described. So let's see, what are the Mars design requirements? And then we drive it back. What do we absolutely have to know? So when it comes to space station, those human health risks. And we have 35, but we're buying them down. That's what we've been doing for 15 years. So we still have some real challenges at the astronaut health, radiation protection. So that's a great example, because what can we do on station? Then we say, what can we do? We're doing a lot of studies, high energy, then low energy physics. And then what about the technologies? What technologies can we look at for possible protection? So that's a great example. But concentrating, as you said, it's 8 years. It's going to go by quickly till 2024. So each intentional, each science experiment, each technology investment, we say, okay, let's take the Mars requirement and then back down. And we have to do that for each of the 3 stages. So that's really what we're focused now on, space station utilization. At the same time, that's what NASA's doing, concentrating on our horizon goal. In the same time, as you know, and all of you know up there, that we're really investing also in the private sector. It's the new NASA. And we have cases on board International Space Station, and they're full up in terms of the manifest, trying to give innovative folks and give industry a chance. What do you want to do in microgravity? What can you do? What's your investment plan? So that's what we're really looking at too. And we're really working with our sister agencies as well, Department of Commerce, because we see a vision then by 2024 where low Earth orbit is commercialized. That's the goal for, in low Earth orbit. Really, we're seeding those, we're seeding that now, but that's what we dream of. The real commercial demand that might take place, and that's great because again, then NASA goes on to deep space and then eventually to Mars.
Thank you. It's interesting you mentioned the commercialization of low Earth orbit, and NASA is just recently, in fact, I believe you actually announced it in your blog that you're working with SpaceX on a public-private partnership to exchange your data for whatever data they might get by sending a Dragon capsule, Red Dragon, to the surface of Mars. I wonder if you could elaborate a little bit on that public-private partnership, and also tell us if there are others in the works in the area maybe of habitat at the moon or in cislunar orbit.
Absolutely. So it's part of the fun part of this job at NASA. I'm in charge of all partnerships, so 700 partnerships with 120 different countries and entities. So it's easier to ask, who aren't we partnering with? Again, it's global exploration to SpaceX, and it's an uncrewed Red Dragon, and so we've extended our Space Act agreement just to do that. Really, it's a technology demonstration. When you look at some of the tall poles to get to Mars, entry, descent, and landing, we're coming in hot. I love Mars. I always say, Earth's my favorite planet, spaceship Earth, Mars second, but EDL to scale it up for the human mission. Because, of course, we can do 1 metric ton, maybe 2, and we've tried every landing system possible and coming into Mars, but this is significant, 10 or more, 20 metric tons. So that's what we really are investigating. That's the research and development, doing that entry, descent, and landing. So that's the recent partnership that you heard about. And the great thing is we're really doing it with a dozen other companies and countries. So it's both U.S. We're really focused on U.S. industry. Of course, you know about our commercial cargo, soon to be commercial crew. And that's how we're partnering, just with everyone in pretty unique ways. I call it the new NASA, and really pushing the partnership, and people have skin in the game as well.
Are there ways to apply that approach at cislunar space in the proving ground? Maybe logistics, or as I mentioned, habitats?
Yeah, deep space HABs, and that's it. So actually right now we have 12 out. So in our next step, BAA, we had phase 1 and phase 2, and that's going out. And so in 3 areas, deep space habitats. And we say it's really, people think, habitat's just the HAB, what this is habitation systems. So sure, it's a hab, but think of the whole system. I'm a systems engineer, so think of all the life support systems. You know, they're complicated, you know, habitat systems. So there's life support, there's the hab itself, but also in-space propulsion. And then we have some satellite work was going on under that next step, and that's it. It's kind of more of the public-private partnerships that we like to do, and that's very focused on Earth Moon. That's cislunar.
Just to continue a little bit on the life support in the commercial, I noticed one of our sponsors is Paragon, which is a life support house. Can you see that?
I can. I see the Paragon folks there.
Yeah.
Tweeting.
In terms of the space station work and the work that would need to be done at the moon before we go all the way to Mars, this is not proper English, but how closed is the loop? How much more needs to be done to actually sustain a crew for the multiple years?
Yeah, about 35% more we need. So when we talk about it, so it's a great example to a space station, what we're doing with life support systems, but the air and the water loops, we need to close them. So we're working on that, but it's kind of incremental. But think about then for cislunar, my dream is that then we get real closed loop life support. And we need to, we're starting, we have the veggie experiment, veggie number 3 on space station. Sure, great to, the crew are enjoying that. Now that's of course a small, kind of 1 cubic meter type of bioregenerative life support, but it's a start. And you envision that. So again, I think we have to think about life support, and rather than the incremental, but what are more of the innovative life support systems that we can think about fielding for specific cislunar deep space. We have to test specifically when it comes to life support in the real environment. Do whatever you can on Earth. Do whatever we can on Earth with the technology and investments, of course, when we're in gravity. Do what we can on space station, and then place those really kind of precious bets, if you will, with limited resources. But the real technology challenges, that's specifically what the plan is for cislunar. So life support is one of those great examples.
Are there anybody have any questions? Yes, I see a hand. And I think someone's going to bring you a microphone. Here he comes.
Oh, hi, over here.
Oh, good. Hi.
Okay. So
I'm sorry. Could you identify yourself, please?
Oh, I'm Gabriella Limberg, and I've actually seen you many times in Pasadena. It's nice to see you here. So on the space station, obviously, there's been opportunity to experiment with zero-G. I was wondering if there's any plans to find a way to experiment with variable G, and in particular Martian G or lunar G.
Right now we don't have a centrifuge. It's a great question, and you might know I'm fascinated with all reduced gravity environments, and so again in terms of many simulations and things at 1G to try to look at the physics, what's possibly going to happen across the whole spectrum of gravity, and but definitely in terms of if you take a look at the down lower to the cellular and things like that, some centrifugation of smaller things, then it really makes sense. And we really do have to think about reduced gravity environments, 1.6, 3As. We know a little bit about them, but there's nothing like really trying to test out. So again, I look at it as kind of an all-out arsenal approach. We'll try to test and simulate in every environment, but the questions about reduced gravity, again, physics from the fluid flow to the human biomechanics to just how all of our systems are going to perform, it's a great question. That's going to be the research going forward.
And I see a question over here.
Josh Mitchell from Georgetown. The Apollo mission story we tell begins with Kennedy and ends, as you mentioned, after the 3 stages, but there's a kind of ambient thing that's surrounding the whole thing, which is the Soviets and the race that we were having with them. So let me ask you the question. Say there's some unimaginable Sputnik-like event. China decides they're going to go to Mars soon. Do you have a get us there plan fast? Have you worked that through? And if that's the case, can you tell us something about that?
We can. Sure, I can tell you about that, but China is going. China has been upfront about their plans for space. So they'll have they're talking about a space station. They'll be at the moon first. Right now, they have no plans, in the near term to be at Mars. And it's talk to the space historians here. I'm just a student of space history, but we plan for cooperative global exploration. We want to lead. We want the U.S. to lead. NASA is leading our journey to Mars, but we're all in, and we want partners of every type. So I don't think it's going to be a single event like that. We're no longer in a space race. We're more into global exploration, but get us there quickly. That's our investments in the Space Launch System. We are under more development than we've been in the last 4 decades, and this is one big, fantastic rocket. And it is being developed, it's being bent. I get to go down and see the metal, the halves, the core module is together. The Orion capsule goes on top, and that's more powerful than the Saturn V. So yes, we have a plan and a rocket. That is our investment in heavy lift launch. And so in 2018 is what we call our Exploration Mission 1. And the Orion capsule will be on top, not with the astronauts. It's EM2, Exploration Mission 2, is when we'll have the first crewed flights into Earth-Moon orbit for SLS. And it'll get us there. It's the most powerful rocket that the world will have seen, and it'll get us there as fast as possible.
Thank you. Any questions? Yes, here. Down front.
Mark Hasey from the German Space Agency. Dava, you just visited Germany and had some talks with our management. That means, and you just mentioned, the international cooperation will be very important for your journey to Mars. Do you plan at some point to stand up kind of officially as the leader of an international endeavor towards Mars, inviting other countries to join, like it was done in the case of the ISS?
Yeah, thanks, Mark. We already have, actually, Administrator Bolden and myself, and so we rolled out what I talked to you about. We had our Journey to Mars plan, and for the last IAC, when we were in Jerusalem, that was the first heads of agencies to have a discussion and invited folks. And we just had a second touch at the Space Symposium. Hope many of you were there. It was a great conference, Space Symposium, and that gave us an opportunity to talk to the heads of agencies again and see where we're at. So the invitation absolutely is out there, and we think the space station, International Space Station, is a good model, but it's not the only model. So we put it out there. We're working. It's impressive. 15 different nations, 5 main partners, and we've been doing this, as you know, for the last 16 years. So we're saying that's there. There's a lot of emerging space countries. They want to participate. So we're saying, here's our map, here's our investments, join us, and who wants to take leadership and other elements. So that's why we're putting it out there, is then ESA and DLR, everyone can say, okay, this is a piece we're really interested in, this is what we'd like to contribute. So the offer is open, it's out there, and then we're working some of the technical details as well. We have what we call our technology matrix and our human health matrix, and that's all been shared, and we've asked for input from all the heads of agencies, and so we're in that discussion. We'll have our next touch with all the heads of agencies will be probably next IAC in Guadalajara, and I'll be at ILA. I'll be at the German Air Show. So I'm over to Germany in a couple weeks to work specifically with ESA and DLR, because we're working very closely with the commitment and the European Ministerial now in 2016 to get the commitment till 2016, because we have NASA, we have Japan, we have Russia, and Canada, and so now we're working really closely with the Europeans to get the commitment for station to 2016 this year. So
24.
2024.
Just to continue on that line, actually one of the former DLR director, now ESA Director General, is very interested in what he calls a lunar village, and that may be, certainly NASA has no plans to return to the surface of the moon. Are you beginning to discuss with our international partners how the moon surface might play into the larger journey to Mars, particularly in terms of resources, partial gravity,
exactly.
That sort of thing?
Yep, we are. We have a lot of discussions with Jan and Dr. Werner and the rest of the folks, and we're saying, though, but what part are you going to lead? If you wanted to lead a lunar lander, we would love that. And guess what? You get a ride on SLS. I sure hope it's a NASA astronaut, going down. So again, thinking about how we can really team. So we're very engaged in those discussions. And again, looking for who's going to step out and maybe take some leadership in that specific case with a lunar lander. That'd be great. NASA will be there partnering with them, and so we'll give them a ride on SLS and look at what astronauts can go, and instrumentation and things like that. So, it's basically station, basically moon, Earth, moon orbit, and Mars, but the moon is definitely is part of the plan for the journey to Mars. So just to be real clear on that, because that's been misrepresented a lot. It is our intention, absolutely, and we'll be in Earth, moon orbit. Right now, we just don't have the lunar lander there. We don't think that we should. We need to have the horizon goal as Mars. We do have a Mars lander in our plan.
And could that lunar lander help with, as I mentioned, resources, the water?
Well, and
how could you use that to go?
In situ resource utilization is one of our big key areas. I mentioned EDL. We have in-space propulsion. Of course, ISRU. Just as an explorer myself, and we know human history. All explorers, the ones that have been the most successful, of course, did live off the land. They didn't take everything with them. We mentioned life support. We need much better life support systems, close the loops, but we really have to think about in situ research utilization. Now, I'm more focused on the Martian one because I said, with our limited budgets, and the reality of it is whatever technology we invest in, but there's still some crossover ISRU technologies. If they're Mars requirements and Mars driven, then we can back that out to see what we do over the next 2 decades.
Any questions? I see one right here.
Thank you. Ray Friesenhahn with TechLink in Bozeman.
Bozeman, Montana.
Thank you.
Shout out for Montana folks coming to DC to visit us.
You were talking earlier about capturing the public imagination and accelerating the pace with limited budgets. And that's really a key goal, and partnership with industry is important to do that. Is NASA considering anything like grand challenges for ISRU or other, say, robotic development for habitats?
Yes, we actually have both going on right now, and thanks for giving me the chance to mention, additive manufacturing. I'm fascinated with it. Again, former MIT professor. I have. We'll just do a quiz here. How many of you have done 3D makers? No, I have my own. I like to see it's generational, right? Because when I ask the girls and boys about that now, a lot more hands go up. But and we do challenges. We do ground challenges, and you named the exact one. So right now, looking at 3D, manufacturing, definitely for habit systems, and we're trying to end up. Probably our largest, just citizen science. It's not a challenge, but citizen science, I have to say that I know where I'll be the 4th of July. I'd love to be in Montana, but I'll be here in DC, and hopefully a lot of you folks are at JPL, because our Juno mission is going to Jupiter, and we're on the countdown. Largest solar-powered platform, the furthest it's gone in the solar system. So we arrived to the apogee, closest orbit to Juno on July 4th, and one instrument on board is called JunoCam. And it's for all of us. Say, hey, public, here's an HD image. You probably saw New Horizons last year, but here's JunoCam. Say, where do you want us to explore? Where should we be pointing on Jupiter? So we're really trying to involve, citizen science, involve small companies to large companies to say, again, how do we get people excited, and how do we need your smarts? How do we have you contribute?
I see a question right here.
Yes, I'm Jared Moore with Magnificent Cosmonauts Podcast, and I was wondering if the international plans that have been shifting towards moon villages will have any effect on going to Mars together. Will NASA astronauts be going by themselves the first couple times most likely, or is there any room for more international cooperation there?
Yep, there's huge room for international cooperation. That's kind of really Frank's message as well. So we know, and that's the ESA paper plan as well. There's no funding line for that, and there's no resources being spent on it yet. It's a great vision, but as I said, we're all in this together. Our vision is Horizon for Mars, but absolutely, if that materializes and there's some real budget resources and some leadership to do a moon village, then we would partner, but we wouldn't lead that.
Right down here.
Hi, Maxwell Silver, University of Arkansas. Has NASA given any thought to the idea of a subsurface Mars habitat?
We have, thank you. So subsurface, looking in lava tubes and kind of natural things. That's usually, there's been some great phase 1, phase 2 smaller studies, especially out of our NASA Institute for Advanced Concepts, looking at those things. And but again, we don't have it predetermined that it will be, look like your grandmother's habitat or something like that. No, we'd love to, back to resources and where can we get radiation protection and shielding. So some places make a lot of sense to look at. maybe go with a lot of the topography, because we can find a lot of protection.
I see Chris closing in. Let's make this one the last one.
Did you consider bringing plants onto the hab on Mars?
We haven't. What's your name?
Peter.
Peter, thanks for coming. You're my Mars generation, because all of us, we're going to see this happen, but it's you. You're going to be the guy with boots on Mars. And what kind of plants do you want to bring? Right now, we're growing some lettuce, and we have some cabbage, and actually some flowers, some edible flowers. We did that because, again, there's a lot of psychosocial, just try to make the astronauts happy. It won't all be potatoes. Did you see The Martian? Not all potatoes, because that'd be kind of boring. So it has to be a little bit more nutritious, but we're thinking about all kinds of different food that we can grow. That's really important.
Thank you, Peter, and thank you, audience. Our time is up. David, thank you so much for giving us the word from headquarters.
My pleasure. Thank you for the conference.